I need to learn these damn right-hand rules. Where are my headphones? Like I said, my apartment's nicer. Yeah, okay. Yeah, okay, buddy. The fuck? This nigga has parents? The way he be acting, I wasn't sure. What's up, Muna? Um. Yeah, I know how to do long straight wires. It's easy. Circular loop. Um, curl fingers, thumb direction of the B field. Oh, okay. Right hand rule number 3. Oh no, there's only 2 right hand rules for that. What's up, Paul? What's up, Mike? Okay. I pretty much learned the right hand rules. And said that's all I needed. I'll just finish this one worksheet and then I gotta lint roll my desk because shit's annoying me. Gotta get this broken pencil off my desk. Guess I'll reassemble it. Let me lint roll my desk first. Of my life. Let me mute it. It's not too loud. What's up? What's up, bro? Let me take the... About to do some pencil paper work. After I reassemble this pencil. This pencil doesn't need any lead in it because I'm gonna see if it works. Oh, this pencil's working now. Okay. I guess if it wants to work now, we can use it. Guess all it needed was a break. There we go. There we go. Why does it count? Yo, what's up, RC? Okay. You deserve it, baby. You deserve it. Hold on. This one. Add existing. Okay, there we go. And I guess we could make it full screen. Okay. Yeah. So I'll need one pencil. Okay. So long straight wire. Circular wire. You curl. Okay, there we go. Out of north into south, of course. So counterclockwise, so we get the B fields going up. So it's gonna be like this. It's gonna be up. So what do we put? How do we do that out of the page? We do it out of the page. Out of the page. Thumb direction of the current. We wrap. So it goes like around it like this. This one's into the page, and this is out of the page. Circular loop, wrap your fingers, B field's gonna go down. That's gonna go straight down. Circular, into the page. 12-volt battery, conventional current's gonna flow this way. 30-volt battery, conventional current's gonna flow that way. So we get this way. We get on the inside, into the page. On the outside, so you go down, so it goes over the top. Out of the page here. If our fingers are curling into the page, then our B field's gonna go left. And it wraps around. We gotta remember that it wraps around. Conventional current. But current's actually just gonna flow in the one direction at 3 volts. Out of the page. Okay. Do you work out daily? Yeah, I do. I exercise daily. Hello, brother. Why don't you use a Mac? Because I'm using a PC. I built this PC. You can't build a Mac, unfortunately. But I do have a MacBook Pro. It's at my feet. What happened to music? Oh shit, I forgot. Hold on. There you go. Can you hear the music now? Were you listening to a different song in your headphones? Yeah, I am. I actually need to skip this song though. Individual charged particles, okay. Right hand rule number 3. Thumb in the direction of the velocity. Your fingers are going to point towards the B field. Oh, so we're trying to find the force. Okay, I actually know how to do this. Yeah. Hold on, I need to change this song. Shit. I guess I can listen to this one. Okay, particle is a proton. Yeah. Okay, if it's a proton, then we just act normal because it's like positive charge technically. Particle is a neutron. There's gonna be no force. No force on a neutron. We went over that. Particle is a proton, so we do thumb the direction of that B field going into the page, so force is gonna go to the left. The axis end of the page, dot is out of the page, so yeah, to the left. No force on a neutron. Particle is an electron, so now we have to use our left hand. We're rolling thumb into the page, fingers towards the B field. We get our palm going upwards. Current carrying wire. We get our thumb in the direction of the current, our fingers the direction of the B field, and then our palms going down. I think. Magnetic force of a current carrying wire. And that's just talking about B fields. What about the magnetic force? Well, a current carrying wire, the velocity of the positive charges is going to be to the left. Fingers are going out of the page, so our force is going to be straight down anyways. Particle is a proton. Fingers direction of the velocity, thumb direction of the velocity. How the fuck am I going to do that? Oh, they're parallel. No force. They're parallel. Yeah, thumb in the direction of the velocity, fingers B field, force is going to be out of the page. This particle is an electron when we use our left hand again. We have a B field going out of north into south. And so left hand, velocity is going down. We have force going into the page. A current carrying wire. Positive charges are going to flow out of the page, going out of north into south. And positive charges going out of the page. B fields, our force is going to be to the left. Okay, last page. Okay, wait, let me just make sure these are correct first. Thanks, Brown. Wait, these are not the ones. Oh, he's doing these ones. I guess I'll figure those ones out then. Wait, why doesn't he have these ones in the packet? So I guess I'll do these ones too. Okay. Currents flowing clockwise of our B field going straight down into the page. We have our current flowing clockwise of our B field coming out of the page. Yeah. Current flowing in a circular loop that's still fingers, wrap, current. B field's gonna go straight down. And it's gonna actually wrap around too. Gotta remember that. Long straight current. So it's gonna wrap around this way. So down low, it's gonna be going up. At point P though, I don't know. Okay, bar magnets out of north into south is our B field. Current carrying wire. B field's gonna go straight up. At that point, I think it's gonna be straight up. Or it might even be like out of the page. I genuinely don't know. Okay, we have two batteries in series. They're working together. We have current carrying wire. We have on the inside it's going to be out of the page. So on the outside it's going to be into the page. Into the page, over the top, and out of the page in the bottom. This 12-volt battery is going to overpower this 8-volt battery. B field's going into the page. B field's coming out of the page outside. Well, I guess we should do the second page as well. Okay. Magnetic force. Particle is a proton. So we get our thumb in the direction of the velocity. Oh my gosh, this is stupid. Thumb in the direction of velocity. Fingers B field. Force is going to be going straight down into the page. Velocity goes straight down. Oh, there's a neutron, so no force. Particle is an electron, so there we go. Velocity straight down. B field is going to come out of the page. Force is going to go to the right. Current carrying wire. So we have our B field going out of north into south. We have our positive charges going to the left. Force or B field going straight down, force is coming out of the page. Yeah. This one's going velocity, B field, force out of the page. Oh wait, velocity, B field, force into the page. Yeah, into the page. Particle is an He nucleus. Okay, so it's a helium nucleus, so if it's just the nucleus, it won't have any electrons. It's a positive charge, technically. With velocity going into the page, fingers B field, forces going straight up. Particle is an electron, so we're going to go thumb out of the page, 4 fingers B field, force to the right. Particle is a proton. So we have a bar magnet going out of north into south. The B field more or less is going down. Particle's a proton. Velocity out of the page. B field straight down, force to the right. Current carrying wire. Velocity is going to be this. Our B field is going to be going into the page. And our force is going to be going straight down, perpendicular to this. Did bro get his pencil? Yeah, this is the pencil that I got. It's fucking sweet. Like you twist this and like the tip like pops in and out just by twisting the top. Look, it's fucking sick. It was so worth it. And I got this pencil working again too, so we're chilling. Into the page. Out of the page, straight down, out of the page, north to south. Yeah, it's exactly what I have drawn on my page. Perfect. Current carrying wire to the right, into the page exactly, to the left, out of the page. Particle is a proton. We have our force going into the page, exactly. No force, yep. Force is to the right. Force is out of the page. Force is straight up. Force is to the right. Force is to the right. And force is down to the left, to the right. All right, perfect, dude. I have these right-hand rules mastered, and I'm pretty sure this entire packet is complete now. There's magnetic flux. It's an alternating current circuit, so not what we're doing right now. Perfect. Now we're gonna go and do the homework. Location. Yo, what's up, Michael? That's a weird ass dream, bro. Man was doing geometry. Okay, wait, hold on. I gotta go grab something. nigga said I have nightmares involving school. It's crazy. I've never had a nightmare about school, I don't think. It's crazy. It's a point charge or no? Yeah, it's an electron. So let's draw this. So our B field is going to be in the plus y direction. And the velocity of our particle, 30 degrees to the plus x-axis. So this is a plus x-axis. So 30 degrees from this. Okay, so this is 30. 60. I'm not 15. What's up, kid on the internet? What kind of iPad do I have? I have an iPad Pro. I got it for Christmas a couple years ago. I was born on January 30th, 2005. That is my birthday. Okay. So this is going to be our velocity vector, and it's going to have components, obviously. We're going to either do cosine of 30 or sine of 60. Either way. We should do sine of 60 though. It has to be the perpendicular. So we have the charge, which is negative 1.6 times 10 to the negative 19 coulombs, times velocity of 2.2 times 10 to the 5th meters per second, times sine of 60. And this is going to be multiplied by the B field with a positive y direction, 1.35 Teslas. Wait, hold on, I just gotta make sure this is correct. Just the magnitude of the force, okay. What the fuck is going on? Bro, do I know how to use my fingers? This calculator is not doing what I want it to do. Go to the negative 14. Okay. I don't know why I drew that whole number. But the magnitude, force is a vector. Do you think we include the negative or no? Do you think it's negative or no? No, it's not. Yeah, I didn't think so. Find the direction of the magnetic force on the electron. Okay, so thumb points in the direction of the velocity, fingers point in the direction of the V field. We get straight up. Our palm is going straight up. So plus Z direction. Oh, I'm supposed to use my left hand. It's in minus Z direction. Because it's an electron. I forgot it was an electron. That was stupid. I forgot it was an electron. When you have an electron, you use your left hand instead of your right hand. What a shame. It's fine. There's G parts to this question, so getting one part, like partial credit's not really that big of a deal. It's gonna be like only minus 20%, so it's not too bad. A charged particle moving in the presence of a 0.75 Tesla magnetic field experiences magnetic force. Find the magnitude of the charge on the okay. Okay, so say we have a magnetic field going straight up. It's just like, it could be going in any direction, but we have a particle moving at a velocity in either direction with an angle of 36 degrees. This is going to be the velocity vector, and this is going to be the B field vector. Okay. So this is going to have, hold on, let me draw this here. This is going to have components. This is going to be V parallel, and this is going to be V perpendicular. So we want perpendicular. So we want sine of 36. V sine 36. And then we're going to get times the B field. So we're solving for what charge? So Q is going to equal F. Hold on. We have a force of 2.5 times 10 to the negative 10th newtons over velocity 1.95 times 10 to the 5th times sine of 36 times magnitude of the B field. We get 2.91 times 10 to the negative 15th coulombs. Or let's actually find this is 0.8. But let's actually find the units. So we're gonna have newtons over meters per second times Teslas. A Tesla is equivalent to a Newton per amp meters. Wait. Yeah, which is equivalent to a Newton coulomb per second meter times meters. So we have newtons over coulombs per second times meters. Oh, shit, my bad. Meters per second. So seconds are actually going to cancel, meters are going to cancel, newtons are going to cancel, and then coulombs is brought out to the numerator. So we'll just be left with coulombs. Bro, why does this problem have every letter in the alphabet? It's the same damn equation. Putting b after sine theta is wild. Why? The sine theta is attached to the velocity. It's like to help understand it conceptually, because the magnitude of the b is not related to the sine theta at all. Good morning. What are your main study techniques? I don't have any. Classical and conceptual physics are different, but you do have to understand physics conceptually to apply classical physics. Yeah. I mean, we can determine the magnitude, but I want to figure out the direction first. The magnitude is the easiest part, but let's find the direction. Okay. The velocity, or the B field, only has a z component. The magnetic force of the particle is in the minus y direction. So we have the force. The B field is going to be here. It's either going to be into the page or out of the page. What's up, Robert? What's up, Nico? The velocity is in the x direction. So you have velocity in the x direction. And it's a positive charge. So we put our thumb. So our B field is going to be coming out of the page. So our B field is in the plus Z direction. Okay. It's a positive charge, right? Yeah. Yeah, perfect. Okay, so B is going to be equal, these are perpendicular, so so our theta is going to be equal to 90, sine of 90 equals 1. So this turns into F equals Q VB. So B is going to be equal to F over QV. This is going to be in Teslas, and it's going to be in the plus Z direction. A highly ionized iron atom, multiple atoms, are found in the sun's outer atmosphere or corona. One such ion has lost 13 electrons. Okay, that makes sense. This ion experiences a magnetic force of blah, 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 newtons. In the XZ plane. Gosh damn it. Hate the XZ plane. I'm gonna have to look at it like straight down. Well, then I would have the XY. So stupid. Okay. 36.9 degrees from the plus x-axis, from the z-axis. What is your mic? Oh yeah, I'll give you my mic. I didn't buy it on Amazon, but I'll give you the Amazon link. I sent you my mic on Discord. Do we want to? I mean, I sent you the link, but you can. You might be able to just put the name there, cause I think it might get the resources page might get overloaded with all these links. Oh, but they're actually pretty small. I don't know why the link is so large when I sent it to you though. If you look at it on Discord. Never mind. I like how it looks right now. It looks really good. So yeah, just add the link to the thing. I also got to do some work / grind this morning. That's sick. What are the prerequisites for classical physics? This class's prerequisites were physics mechanics and calc 1 and calc 2. And all those classes have their own prereqs as well. Calc 1 has prereqs, like algebra, but I mean, you should have gotten those in high school. And then physics, classical physics also, or not classical physics, physics mechanics also has a little bit of prereqs. Why do I miss being in class? Because it's sick, bro. Got assigned a last minute deliverable and job wanted it done within a day. That's crazy, bro. Which OS even is this? This is Ubuntu. What's your major? I'm studying physics, and I'm doing a master's in computer science. Oh, you shortened the link. Yeah, that's good. I don't know how you did that, but yeah, that's fire. Let me close the Discord. Getting me distracted. I need to finish this question then. I gotta do something. Okay. Oh, we're gonna draw this out. So we're gonna draw a ZX graph here. It's both in the positive Z and the positive X. So it's velocity. Okay. The direction of the force is going to be, so we have components. So velocity is going this way. Our force is going to be out of the page. And if this is a positive x, z, then that's going to be in the positive y direction. Because otherwise we're saying velocity goes to the right. This is going to be our velocity, our x component at least. And then we have a B field here in the positive z direction, so that's out of the page. And if we do fingers, wait, why is it going down? Wait, is a positive charged ion? Yeah, it's lost 13 electrons. B field's out of the page. Wait, I'm saying the force is down actually. Velocity. Force is out of the page. Wait, I'm actually getting forces in the negative y direction. Wait, is the plus z direction, the plus z direction's out of the page. Yeah, plus z direction's out of the page. I get the forces in the negative y direction, actually. Wait, but if we're looking at a graph from the plus x and plus z direction, is out of the page negative y? Oh yeah, it is. Yeah. Okay, so we get the negative y. Okay, let's find the magnitude. Right. What are we solving for? We're solving for b. What's the force? 2.3 times 10 to the negative 15 newtons over the charge, like 2.08 times 10 to the negative 18 coulombs times velocity 7.3 times 10 to the third. Yeah, perfect. So when we're looking at a positive x, positive z graph, out of the page is negative y direction. You add it to the resources. Bro, how do you shorten the link? I don't understand. Oh, like that. Fire. Good job, buddy. He said my apartment's nicer. Right. I was gonna say I already saw that, but it's a different person. Nah, forget it. Forget what, dude? Roger Federer's commencement speech at Dartmouth. Okay, what's going on here? 2 times 10 to the negative 4th kilograms carries a negative charge. North. Okay, dude. Bro, north, south, east, west. That's what we're doing now. Wait, what? What is the magnitude of the minimum magnetic field that will keep the particle moving in the Earth's gravitational field in the same horizontal northward direction? What the fuck is it talking about? Okay, I get it now. Okay. What are we solving for a B field? That is due north. The force is going straight south. That's not possible. The force has to be perpendicular to both the velocity and the B field. What is the direction of the minimum magnetic field? Okay, so we have our left hand here. The particle horizontal velocity that's due north. Is north not vertical? Check resources and tell me how you feel. What you think. Let me see. Oh, that's fire. Yeah, that's fire. How'd you do that, bro? That's sick. Yeah, bro, that's fucking sweet. It's way better. It looks way cleaner now. Oh, yo, I forgot to be plugging the Discord this whole time. Does that invite link still even work? I think it's permanent, so. Wait, hold on. I need to check the invite link in the description. Should be perma, though. Yeah, it is. It's permanent. You sent me the permanent one? Alright, bet. Let me see. I'm just gonna replace my links with that one. Thanks, bro. Thanks, bro. Alright, what's going on here? Okay, the particle is given an initial horizontal velocity that's due north. Yeah, that's really horizontal, dude. Straight up. Okay. Okay, north is this way. Our force is gonna be straight down. Oh, our force is gonna be straight up. No, our force is supposed to be north. The fuck is going on? The force should be north. Yo. Are you using Ubuntu? Yeah, I am. The minimum magnetic field oh wait, because north, south, east, west is only in 2 dimensions. Oh shit. Okay, wait, hold on. I'll be right back. I'll be right back, like 5 minutes. Bro says he's got a lock in. See you, bro. Lefty. Okay. Velocities and then so we know the force of the B field is going to be going straight up to oppose gravity. And the velocity is pointing in either direction. Oh, I get what it's saying. Okay, so velocity is going straight up. Force is going out of the page. Okay, so that means our B field is going to the right. This means this is our B. Okay, it should be going east. Okay, that's what it means. Because it's like if you're flat on Earth, your velocity, you're walking north, your velocity is north, but your normal force is straight up, like literally straight up, like out of the page. So you're walking north and your force is out of the page. So now we just have to solve for the magnitude of the B field. Theta equals 90 degrees. Sine theta equals 1. So B is just going to be equal to F over QV. So our force is going to be this number here. And then our charge is... Oh, it's a negative charge. Fuck. So everything's the opposite. The B field in the west direction. B field goes west. You gotta do your left hand. Velocity straight up. Wait, what? No, but the force is out of the page. This is if we're in an area, if we're at an aerial view. Wait, so the B field is actually still to the... Yeah, no, the B field's still to the right. The B field's still east. Left hand. B field's to the east. Yeah. The charge of the particle is negative 3.2 times 10 to the negative 8 coulombs times 4.5 times 10 to the 4th meters per second. Okay, so we got to make sure that this is going to be equal to Tesla's. So we have newtons over coulombs times meters per second. And that's also equal to newtons over coulombs per second times meters, which is equal to Newton amp meters, which is equal to a Tesla. Perfect. So we get 1.3625 Teslas. Yeah, perfect. I already saw that. A 27-lane highway. Should we add more lanes or no? What do you think of the Feynman technique? I heard it's very effective. The Feynman technique is very effective. Yeah, the Feynman technique is great. 100%. That's something that I've actually done before. Oh my gosh, I want Chipotle so bad right now. That's crazy. I'll get a I did try it, bro. Yeah, that's good. No, Feynman technique is great, bro. If you're able to teach something, if you're able to teach something to someone, then you 100% understand it. I mean, Feynman kind of, well, I don't know who said it first, but Einstein said the same exact thing. And Feynman and Einstein are from the same generation, so maybe they collaborated on like making the technique. But Einstein said, if you can't teach it to a room of kindergartners, then you don't truly understand it. Which I couldn't teach physics to a room of kindergartners because that's kind of crazy. I don't understand physics that well, but I mean, because you just have to teach them so much stuff. But I could explain physics to my classmate for sure, and that's helped me a lot. Tutoring my classmates has actually helped me a lot on my exams because it helps me understand it and like learn more. Because you have to not only understand it, but you have to be able to understand it and put it in a way that other people understand it. And in doing that, like you gain a deeper understanding of it. It's kind of pretty cool. But yeah, 100% that shit works. Okay. A particle with mass kilograms and a charge, blah, 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 has at a given instant a velocity in the positive j hat direction. What is the magnitude of the particle's acceleration produced by uniform magnetic field in the j hat? What? How's its velocity going in the same direction as the B field? It's 0. Wait, what? The velocity is going in the same direction as the B field, so there's no force acting on it. Force equals 0. So acceleration equals 0. Wait, what? Oh, sorry, I didn't see the components. It has I hat and j hat. Okay, I'm sorry. I'm trolling. So we're only concerned about the B perpendicular. Sine theta is going to equal 1 again. Theta equals 90 degrees. We're going to have velocity going in the positive j hat. And the B field's going in the positive I hat. Okay. A equals QVB over M. And the acceleration is going to be pointing in the same direction as the force vector. So thumb velocity, this is a positive charge, and a charge of 1.22, yeah. So force is going to be into the page. X, Y, H, J, K, so K is Z, so into the page is going to be negative K. Yeah, negative K. And if we just think about it, like if we're standing here, we have X and Y. Well, I guess it would be X and Y. And going straight down would be negative Z or negative K. Okay, so now we just need to find the magnitude, which is just my calculator. charge 1.22 times 10 to the negative 8 coulombs times velocity 3 times 10 to the 4th. And then we have only the I hat direction of the B field, 1.63. And this is going to be divided by the mass is 1.81 times 10 to the negative 3. And we get 0.3296 meters per second. But we got to make sure equals coulombs meters per second, Newton coulombs per second, meters over meters. Wait, we actually have a little bit of a problem here. Our seconds are actually looking like they're going to cancel out, which can't be possible. Our seconds need to square. Wait, so is B in the wrong place? MA equals QVB, but that's right. Wait, hold on. Can we figure out... Oh, wait, hold on. We have kilograms times meters per second squared equals coulombs times meters per second times... A Tesla is a Newton per coulombs per second times meters. Our meters cancel here. Oh, that's why. Our seconds cancel here, and our coulombs cancel here. And we have newtons, and a newton is equivalent to a kilogram meters per second squared. So if we divide both sides by kilograms, we're left with meters per second squared. Yeah, exactly. Wait, but 0.3296 does not seem correct. No, yeah, it seemed correct to me. I'm just kidding. Yeah, I didn't think that was right just because it's so small. Einstein to G. That's kind of right. When I take the exam, people ask me to explain the subject. Yeah, exactly. That's why I love studying with other people. Well, I actually like studying by myself the most, but studying with other people has its benefits too, because you have the built-in Feynman technique. It's like forced Feynman technique. Okay. So this is a magnetic cube. Magnetic cube with sides of length A is moving at velocity v naught j hat across a uniform magnetic field b naught k hat. Cube is oriented so that four of its edges are parallel to its direction of motion. Are we trying to find the direction of the E field? The E field? How does the E field even relate to this shit? E field flows from positive to negative. Conventional current flows from negative to positive. Yeah, I have the new calculator, look. I'll show you it. Fuck, where's the calculator? I fucking hate this case. Yeah, look, I have the calculator up. See? It finishes all my sentences. There's like something you can do with like graphing shit. There we go. Look, you see it and it graphs it. Wait, but there's something else you can do. You can do like plus t, and then you say like t equals 1 here. Bro. Missing coefficient. What do you mean coefficient? You don't need a coefficient. Whatever, dude. Let's try z. Maybe z will work. Whatever, bro. I don't know what's going on. I don't know what's going on. Doesn't make any sense. Okay. Well, the E field is equal to E field, bro? I don't think this is like he meant to ask this question. How am I supposed to know what direction the E field is flowing? So we have a particle is moving. Zero? Fucking hell. What the fuck is it talking about? Oh, this is easy. V naught. V naught. B naught. Q. Find the magnetic force direction. That's easy as well. This is positive. I can't tell if this is positive or negative charges. I guess it doesn't. No, it does matter, but velocity to the right. So force is coming positive z. Or I think it's IJK. So positive I. Bro, where the fuck is I hat? The fuck is going on? Can we get the keyboard to go away? I. Bro. How do I type a I hat, bro? Vector. No. Where the fuck is I hat? Can I just copy it? Bro, hello? Fuck. Bro. No. Bro, can we get... Oh, where is I hat? How to type I hat? Oh, there we go. I didn't see that button. Mine's missing that button. No matter what, it's gonna be I hat. Okay. Yeah, right, dude. Okay. Thanks a lot, bro. I really could type that in to my fucking answer. You kidding me? Yeah, negative I hat. That makes sense. Because it's an electron. What is FE? FE is going to be equal to FB. Oh, no. I just use Q, E. Variables are case sensitive. Yeah, I know that, dude. Is it stupid, bro? F equals QE. Okay, great, thanks. Bro, Pearson is stupid. Do you see this? I can't type these answers in. I literally just can't type these answers in. E is just going to be equal to this is just going to be E naught, V naught, B naught. Because look, the force of the B field is equal to V naught, B naught, Q. This is also going to be equal to the force of the E field. V naught, it's just gonna be V naught, B naught. And I can't enter the... Bro, it doesn't let me enter the I hat. Or J hat or any of this stuff. Bro, this is actually ridiculous. It's the same thing. Oh, there we go. Okay, you do backslash. Alright, bet. Thank you, bro. Latex. I had to write latex in my CS 173 exams. All of our answers were in latex. Alright, bet. V naught, B naught, and unit vectors. Okay, so it's going to be equal to V naught, B naught, but we have to find its direction. So if we have negative charges moving to the right, and that's why our force is going to be negative I hat. Negative charges moving to the right, from negative to positive. So it's going to be Y. It's going to be J hat. Bro. It's gonna be J. Wait. Hold on, let me go back to electric field and forces. Okay, electric fields. Wait, so if we have an electron moving to the right, wouldn't that go to the right as well? Correct answer does not depend on J hat. What the fuck, dude? You can do it? Yeah, right, dude. This is fucking stupid. Bro, they're asking dumbass questions. This doesn't, like, has nothing to do with how good I am at physics and everything to do with how good I am at reading their stupid ass problems. Oh, I guess we do need to know the force. The force of the B field is what? I hat? It's negative I hat. So the force of the electric field is going to be positive I hat. Wait, so if the electric force is going positive I hat, then what does that say about the field? How do fields and forces relate in electricity, bro? Let's look through this damn packet. Oh, calculus of the fields. Wait, so does force and electric field point in the same direction? So it's going to be positive I hat is actually what I get now, positive I hat. Wow. Wait, how's it negative I hat? So stupid. If one replaces the conducting cube with one that has positive charge carriers, in what direction does the induced field point? In the positive I direction. What? The equilibrium will be the same. Oh my gosh. Physics is a mandatory class in CS at your university, yes. What's Pearson? Something that should have never been invented. This is such a joke. Every aspect of this website's a joke. Hello? My desk isn't listening to me. Early congrats on 4K subs. I hit 4K subs since when? It says early congrats though, so not yet, huh? 3.93. Damn, bro, it's kind of crazy. Okay, can we do like a problem where they're not asking me the most stupid shit of all time? An electron at point A. How's the speed V naught? Okay, it's fine. "10 centimeters. Okay. This is so stupid. Oh, gotta get a 4.0 now? Yeah, I do. So stupid. Okay. We're just gonna assume they're perpendicular. I guess so. Okay. Charge of an electron is 1.6 times 10 to the negative 19 coulombs. V naught equals 1.1 times 10 to the 6 meters per second. Mass equals, what's the mass of an electron? Isn't it like 1.6 times 10 to the negative 19? Oh no, it's not. Wait, I've never used this equation though. Oh, a proton's mass is 1.6 times 10 to the negative 19. Oh no. Oh yeah. Times to the negative 27th is a proton. Oh my gosh, why are we... Okay, yeah. 9.11 times 10 to the negative 31 kilograms. It's ridiculous. Okay. What other variables do we know? We're solving for the B field. We need to find the acceleration. So distance equals 0.1 meters. So okay. Wait, hold on. So assuming gravity's acting on it, yeah? Yo, Elijah, everything's in the Discord. If you join the Discord, you go to resources, you can see my entire setup. That's not the one that I have. Did I return that one? Yeah, wait, this isn't a Logitech. Bro, wrong search bar. Gosh fucking damn it. Wait, whose webcam is that? See my dad's. Should I get a new webcam? I should. It's time for me to upgrade. Okay, I'm getting a new webcam. See if it's in stock in Cedar Rapids. Yeah. So I just gotta bring mine in, total tech it, and then get a new one. Jerry West passed away. Who's Jerry West? Yeah, I have no idea who this is. Looks like he died about 3 days ago. The NBA logo? Yeah, I really do not know who this is. That's sad. That sucks. R.I.P. Okay, wait, what was that? Okay, so we have the distance. Oh, I was right. Are we going to assume that gravity is acting on it or not? Because if we assume that gravity is acting on it, then we know the time in the air. But if we don't assume gravity is acting on it... Oh, gravity has to be acting on it. Or else it wouldn't be parabolic. It'd be like asymptotic. Okay. So here's our electron. We have the force of the magnetic force. We have V naught. So, well, there's technically really no force moving in that direction, but we have mg. So the acceleration is 9.1. So delta y equals v naught t minus 1/2 at squared. So this is a quadratic equation. So on my calculator, I should be able to do quadratic equations. Math? No. Well, I can do it on this one, I know. We go to tab. Oh no, menu. Algebra, polynomial tools. Find roots of a polynomial. Degree 2. Roots are real. Ax squared is going to be negative 9.81. A1 is going to be v naught t. What's v naught? 1.10 times 10 to the 6. Hello, dude? Wait, what? We're going to be in the air forever. Wait, this is not the right equation to be using. Hold on. We need to get time first. We shouldn't be solving this equation for time. To get time, we're gonna do v naught, or no, v equals v naught plus, well, I guess it's minus at. And when this is 0, (1.1 times 10 to the 6 over 9.81). Dude, that's like a crazy ass number though. 112,130 seconds. So times that by 2, now we get the total amount of seconds. This is fucking stupid. Like, this is like really stupid. No, I mean, it's definitely a parabola. Bro, that's what I was thinking. I didn't think there should be gravity. It makes no sense for there to be gravity. But if it has initial velocity upwards, there has to be a force acting downwards for it to be a parabola. A semicircle is a parabola. It's the same thing. It's the same thing. It's parabolic. Yeah, it's the same thing. Ask ChatGPT. Bro, if you draw a parabola, look, let's draw negative x squared is going to look like this. This is a semicircle right here. If you draw x squared, this is a semicircle right here. This part of the parabola is a semicircle. It's parabolic. But it's pointless to talk semantics. There has to be a force acting downwards for it to have, for the velocity, like there has to be an acceleration downwards for the velocity to go down. The velocity vector changes from up to down. So there has to be a force acting downwards. And so are you saying like, no. I mean, the only way if we ignored gravity, the B field would have to have an X and Y component to it. Yeah, it shows the path of the particle. Yeah, dude, I don't know what you're talking about. Okay. Since this is centripetal, acceleration equals v squared over r, so F is going to equal mv squared over r. So we have mv squared over r equals qvb, right? And we're trying to solve for b, so b equals mv over qr. And then we just plug in numbers. That's stupid. 9.11 times 10 to the negative 31 kilograms times 1.1 times 10 to the 6 meters per second divided by a charge of 1.6 times 10 to the negative 19 times the distance of 0.1, yeah, just 0.1. And if we put this in my other calculator, because we want scientific notation, we get 9.11 times 10 to the 31st, negative 31st, times the velocity, 1.1 times 10 to the 6, over q, which is 1.6 times 10 to the negative 19, times r, which is 0.1. And we get 6.26 times 10 to the negative 5 Teslas. It's like really small. Oh, but since it's a circle, that's the diameter, so we want to use the radius, which is 0.05. R equals, what am I doing? 0.05 meters. So now we get 1.253 times 10 to the negative 4. That's so stupid. Okay. Find the direction of the magnetic field that will cause the electron to follow the semicircle path from A to B. Okay, so we have our force acting to the right, obviously, to the right and down. Our velocity is going up, force is going that way, so into the page. Find the time required for the electron to move from A to B. Okay. Yeah, but the force isn't acting directly downward, is the only problem. We need like an angle or something. We need to know the components of the force. I guess we can solve for the acceleration. Yeah, but don't we want the acceleration in the x or y direction? This is so stupid. Our V is going to be equal to... We already have V. What are we talking about? We already have V. Oh, that's V naught. Yeah, it was the same. So we do pi times 0.05 over 1.1 times 10 to the 6. This is maybe the stupidest problem of all time. Is statistics hard? Yeah, I mean, AP Stats wasn't too bad. But that's a high school course, so. An isotope of hydrogen. Okay, find the speed. So velocity is going to equal BQ R over M. So B field's 2.3 Teslas times coulombs, 1.6 times 10 to the negative 19 coulombs. It's a proton. Times the radius of 6.5 times 10 to the negative 3 divided by the mass. 3.34 times 10 to the negative 27 kilograms. Okay, and let's see if the units work out. So we have Teslas times coulombs times meters over kilograms. So we get newtons per coulombs per second times meters times coulombs times meters. So meters, coulombs cancel. So we get newton seconds per kilogram is going to equal kilograms times meters per second squared times seconds. So these cancel over kilograms cancel. So this is just going to equal meters per second. Okay, perfect. So this is correct. 7.162 times 10 to the 5th. Find the time required for it to make half of a revolution. So time equals pi r over v equals, oh, so we have the actual answer. Pi times 6.5 times 10 to the negative 3 over that. Divide that by 2. We get 1.4257 times 10 to the negative 8 seconds. You fucking kidding me? Okay, let's calculate this again. Pi times r is 6.5 times 10 to the negative 3. Divided by 7.1612 times 10 to the 5th. And divide that by 2. Oh, to make 1/2 of a revolution. That's a full lap, like, because it's circle. I was doing half of a semicircle. So half of a circle would be the full semicircle. Idiot. Through what potential difference would the deuteron have to be accelerated to acquire this speed? My fucking gosh. Okay. So we know that hold on. We need to relate this to potential difference. So where's the thing? Oh, this is that's what I've been looking for. That's the paper I've been looking for. Okay. But voltage equals KQ over R. But there's also other ways to relate voltage to this. Voltage is also equal to the E field times the distance traveled, which is going to be equal to the force over the charge times the distance. So this is going to be equal to F times pi r over Q. So we'll try both. They both should get the same answer. KQ, so K is 9 times 10 to the 9th times 10 to the 9th. The charge is 1.6 times 10 to the negative 19th coulombs, and divided by the radius, which is 6.5 times 10 to the negative 3. Negative 7th voltage? That's not possible. Yeah, right, dude. Okay. Let's do F. F equals mv squared over r. So the mass is 3.34 times 10 to the negative 27th. V squared is, gosh damn it, 7.1612 times 10 to the 5th squared. mv squared over r, 6.5 times 10 to the negative 3. Negative 13th force. Okay, that times pi, and then times 6.5 times 10 to the negative 3. Oh, so they just cancel. We can actually just take the numerator of this times 2 pi. Oh no, times pi. Yeah. And then divide that by the charge, 1.6 times 10 to the negative 19th. We get 3.36 times 10 to the 4th volts. That's not possible. What the shit? Think about what other voltage equations we have here. Yeah, but that voltage is absurd. There's no way. .3632 times 10 to the 4th. Yeah, no. There's no way. 10 to the 4th voltage, bro? Should be like 100 volts. No, I don't know what it should be, but it shouldn't be 3 times 10 to the 10 to the 4th. And that's not even possible. 30,000 volts. Well, I guess that is possible. I mean, our power lines after a transformer can be boosted up to like 120,000 volts. I'm just not getting this. Took 10 kilowatts to run. Yeah, it's crazy. I'm just trying to think of like what equations it wants me to be using here. Oh, I also could have just done F equals QVB. 1.6 times 10 to the negative 19th times velocity 7.1612 times 10 to the 5th times a B field of 2.3. We get 2.6 times 10 to the negative 13. Yeah, it's the same answer we got earlier. Force times distance, which is pi r. Pi times 6.5 times 10 to the negative 30. Over Q. 1.6 times 10 to the negative 19th. Yeah, I would get the same answer, 30,000. Why are you on a new physics topic every week? Because it's a summer course, so it goes really, really fast. It's a 16-week course in 5 weeks. So there's exams every week. And each exam covers different topics. So this is generally stuff that would be covered over like 16 weeks, but now it's just 5 weeks, so we're moving really fast. Next week I'll be on optics, but this week we got to focus on magnetic fields and forces, and then alternating current and time-dependent circuits, which is stupid stuff. But I can't get this question correct. I don't know what I want him to do. Okay, we can also use energies. So, okay, we can also use energies. Like we can say 1/2 mv squared is equal to q delta v. Okay, whatever. 1/2 times the mass is 3.34 times 10 to the negative 27th times v squared 7.1612 times 10 to the 5th squared. And then divide that by the charge, 1.6 times 10 to the negative 19. Bro, we get 5,000 volts. Like, that's also not going to be the answer, I don't think. What? Yeah, but I don't understand how we tried all these different other methods and they all didn't get the same answer. Kilovolts. Well, I guess here's 2,000 more volts of transverse magnetic field. Circular arc with a radius of 0.185 meters. This is fucking stupid. Okay. So we have mv squared over r is going to equal r qvb. We have r equals 0.185 meters. We have potential difference equals 2.08 times 10 to the 3 volts. We have mass equals an electron, so it's what, 9.11 times 10 to the negative 31 kilograms. I'll have to Google that to make sure it's correct. And then the charge is going to be equal to negative 1.6 times 10 to the negative 19 coulombs. What is the magnitude of the B field? Okay. B is going to be equal to mv q over r. Is that how that works? No, divided by q. mv over qr. Okay. So we need to solve for velocity. And that's it. So our velocity, we know that 1/2 mv squared is equal to q delta v. Oh, we know q and delta v. So just multiply it by 2 divided by velocity equals 2q delta v over m. Okay, q is 1.6 times 10 to the negative 19th times delta v is 2.08 times 10 to the third, and then multiply by 2. And then now divide that by the mass. Oh, we were right. We're going to look up mass of an electron. See if I was right. 9.11 times 10 to the negative 31 kilograms. So I was right. Okay. 9.11 times 10 to the negative 31. Yeah, and then we get the square root of that answer. And that equals 2.7. What the shit? That's not possible. Tesla's? Oh, sorry. This is velocity. This is velocity. That's totally possible for velocity. I was like, what the fuck? Okay, so we do 9.11 times 10 to the negative 31 times the answer divided by q, which is 1.6 times 10 to the negative 19th, times r, which is 0.185 meters. Yeah, and that's a possible B field. 8.3191 times 10 to the negative 4th. This is going to be in Teslas. And we got to make sure that this is in Teslas because, so we get mass is kilograms times meters per second over coulombs times meters. Okay. And a Tesla is supposed to be kilograms times meters per second squared over coulombs per second times meters. So these seconds actually cancel. And these meters cancel as well. So we should get kilograms per coulomb. Oh, coulomb second. Kilograms per coulomb second. So these cancel. Yeah, kilograms per coulomb second. So yeah, it's Tesla's. Fire. Yeah, that's why the last one didn't work, is because I was using the electrostatics equations. Yeah. I mean, it felt kind of wrong using those equations, but I thought it was going to be right. But yeah, that makes sense. I mean, electrostatics obviously would have different conditions for the equations than moving charges through a magnetic field. Thanks for the justification. My fucking gosh, I thought we were done with the bullshit. Okay, I only have 3 questions left, so. See what my phone has to say to me. What's up, George Phillips? Bro. Thoughts? Thoughts on what, bro? Bro didn't answer my phone call? Okay. Whatever, dude. Whatever, dude. Don't respond to me. I don't care. Man's ignoring my question. Let's see. What was your question? Can I still get a physics degree even though my IQ stands at 75? How's everyone? I'm chilling. But yeah, you can. IQ doesn't matter. We've talked about this like a billion times. IQ doesn't matter for a physics degree. It's irrelevant. Completely irrelevant. You should just ignore IQ test at all. Don't even think, like, IQ test literally. If you ask your physics professor if they've ever taken an IQ test, they're probably gonna say no. They're probably gonna say no. I've never taken an IQ test in my life. It's irrelevant. You shouldn't have even taken an IQ test in the first place. So don't even think about it. No, not today, dumbass. Gosh damn it. Dumbass is kind of crazy, but. 3 more questions. Light work, bro. Light work, no reaction. I might be the hungriest person to ever live. Got a response yesterday from Ethan. Have you gotten any marks back? Yeah. No, don't take IQ, bro. If I asked any of my classmates if they've ever taken an IQ test, they would say no. It doesn't. It's stupid. I've taken an IQ test, but only because I took it in AP psychology. Like, my class did it as a social experiment, and they wanted to see if it was bullshit, and it was. Like, we had a whole unit in AP Psych about how IQ test is literally irrelevant in everyday life. Well, I mean, to some extent, right? But for the most part, it's not a good I mean, is determinator a word? But yeah, of like a person's ability to do anything. Have you gotten any marks back? I've gotten a ton of marks back. My transcripts for my first 2 semesters are on my website in the header, and then I've gotten every exam score back from this class so far. But I have an exam on Monday, which I obviously haven't gotten my marks back on that one yet because I haven't taken it yet. Oh, I gotta do that lab too, the take-home lab. I don't even know where that shit's at. I keep forgetting to do them, and then I'm like, it's like right before the test, and I'm like, oh shit, wait, I didn't do the take-home lab. Should be somewhere. Magnetism take-home lab, here it is. There it is. I need Chipotle bad. I need to finish this homework assignment and go get Chipotle like really, really badly. I might like die if I don't eat Chipotle. No, should I just wait until I'm leaving at 3 anyways, so should I just wait till 3 to eat? Boo. Boo. Can't believe I was listening to music that loud, bro. No, I can't go. I can't go. I have to finish this homework assignment. I'm gonna do the calc, and then when I end stream at 3 o'clock, or well, at like 3:45, then I'll go. Can never chill. No chill, no chill, no time to chill. Okay, a particle with the initial velocity v naught j hat and the region of uniform electric magnetic field. The magnetic field in the region is negative k hat. You can ignore the weight of the particle. Once you need to calculate the electric field volts per meter. With the particle of 0.64 times 10 to the negative 6 coulombs. Okay, so let's write everything we know. We know V naught equals 5.85 times 10 to the 3 meters per second. We know the B field. Let's just do magnitudes for now. Is 1.35 Tesla. We're gonna ignore the weight of the particle. That's great. The charge is equal to 6.4 times 10 to the negative 7th coulombs, right? 0.64 times 10 to the negative... Wait, nanos to the negative 9th. 6.4 times 10 to the negative 10th coulombs. Wait, nanos to the negative 9th. Nanocoulombs to coulombs. Brah. .64. Right, that's how many it was? Yeah, 6.4 times 10 to the negative 10th. Yeah, exactly. Okay, so now we need to find the magnitude of the E field. So we know E field is going to equal... Okay, wait. Hold on. We got to write all of our equations. So we got F sub B equals V naught B Q. Right, QVB. Let's write it normally. QVB. And we know that F equals QE. So E is equal to QVB over Q. So E is just equal to V naught B. .85 times 10 to the third meters per second. Why is it written like that, dude? Times the B field of 1.35 with 7.8975 times 10. Perfect. What is the direction of the electric field? Okay, so V naught is in the positive J hat, sorry. Positive J, so this is V. We have a B field in the negative K, so the B field is gonna go into the page. So this is a particle with positive charge, so velocity goes up, B field goes into the page, force is gonna go to the left. We have force going to the left. So this is the negative I hat. Force is the negative I hat. What year in uni should you start worrying about building projects? You should never worry about it. You should only do projects because you genuinely enjoy doing the project. You know what I mean? Like, when I do projects, it's just because like I'm curious. I'm like, okay, I'm curious about this. I should do this project so that I can learn about this. It's never like I have to do a project for my resume. I feel like if that's the reason you do projects, then you're not gonna have a good time doing projects, and your projects aren't gonna be very good. So, if you never want to do a project, then don't do them. I mean, that's probably not the best, but I would say you should just take it at your own pace and do projects when you feel like it. But I would say like a good rule of thumb, I guess, would be to have maybe 1 to 2 projects per school year. Yeah, I mean, they're pretty essential. So like if you want an internship, then you're just gonna have to have projects. And that's I'm saying 1 to 2 per school year. Last school year I did 2 projects. It was pretty chill. I'm doing a couple projects this summer, and I'm gonna continue doing projects over next school year as well. Are you planning on becoming a data scientist or a data scientist or a software engineer? No, neither of those. Yeah, I definitely don't want to be a software engineer, and I probably won't become a data scientist. What do you to write your calculations? I imagine you're asking what do I use? I'm using an iPad. Even if math is your weakest point, you can still study physics. Of course you can still study physics. Math is everyone's weakest point until they learn math. If math is your weakest point, it just means you haven't been taught math well enough. It's not It's not on you, it's on your teacher. You're not going to understand math that you've never learned. It's not possible. Is it also valid, though, to use the projects, the courses assigned throughout the semester? I'm first year, so just curious. I'm first year as well, and I don't think it's valid to use projects that the course assigns throughout the semester. I think that's pretty fraudulent. I mean, if I use like my CS 128 projects, now I use second year now, not till the summer semester is over. Yeah, I mean, if I use my CS 128 projects, that's like cheating, dude. I mean, they made us do like 7 projects. So, I mean, my resume would be stacked with all these stupid projects, but they're too intro. I mean, if the course project, if it's like a 500 level course or a 400 level course, which means I get to graduate like research-based course, then you probably could. But for 100 and 200 level courses, I would say you like cannot use those projects. Just because one, they're stupid. Like those projects are not going to be anything worth looking at for an employer. And secondly, it doesn't require any creativity. It's not really your project. It's like a homework assignment. It's like me putting a homework assignment on my resume. But once you get up to the 400 level classes, like they make you write your own projects and you actually have to write like your own stuff and do your own stuff, then I would say you can use those ones. Can you recommend any math textbook? Transcendental's Calculus by James Stewart for Calc 1, 2, and 3. It's a goated book. So you work part-time or anything? I do not work part-time. Didn't realize you were a rising sophomore. Keep it up, bro. Thanks, brother. Yeah, I'm about to be a sophomore in the fall. Do you plan on going further than undergrad for CS/physics? Yeah, I'm doing a master's in computer science, like literally right now, concurrently with my bachelor's in physics. And then I'm going to do a PhD in machine learning. And, well, I don't know what my PhD is going to be in, honestly, and it's in such a long time. It's probably going to be in 4.5 years is when I graduate from my master's degree. Well, 4.5 years from when I started, so 4 years from now. But, oh wait, no, 3.5 years now is when I graduate. So I graduate my bachelor's degree in 2.5 years, right? No, I graduate my bachelor's degree in just 2 years. Yeah, I graduate my bachelor's degree in 2 years, and so my master's will probably be done in either 3 or 3.5 years. Oh, 3 years. So yeah, I don't know what I want my PhD to be in machine learning and neuroscience right now, but maybe I'm feeling like something different when I get there. Do you play video games anymore? I do not. I do not play video games. I haven't played video games since like I think last year. How do you know what you want to do already? That's what I was saying. Like I know what I want to do right now. But maybe in 4 years or whatever, it'll change. So I'm definitely open to change, and I love it. I love change, actually, because it requires acceleration if you're talking about like physics. But in real life, it's kind of like the same thing. Like change in direction at least requires acceleration. It requires like hard work. So I really like changing because it makes me have to work at something new. Do you like Macs? I do like Macs. I love my MacBook. It's right next to me. I always thought that when a student fails a course on math, they are most likely accountable for their mistakes. Well, okay. Okay. Well, that's a little different. I didn't know you were talking about failing a math course. I thought you were just saying like there's math that you don't understand. But I mean, of course, people fail math courses all the time. It's not really that big of a deal, but it definitely is on you. It's not to say that you're like you're bad at math because you failed a math course. It's more of like you just made mistakes during the course. You probably didn't study enough, and you probably didn't study. If you did study a lot, then you probably didn't study correctly, and you weren't pursuing the right resources to help you learn it. So I would say if you failed a math course, you obviously should retake it and maybe go to office hours and stuff, learn from the TAs and learn from the teacher, watch YouTube videos and stuff. It's nothing that you can't understand. What are your thoughts on software engineering? I'm a SWE right now and want to see what others think. Yeah, I mean, software engineering is cool, but I'm personally am not interested in going into it. But it depends. I mean, software engineering is pretty nuanced. There's a lot of different roles in software engineering, so it depends on what type of software engineer you're talking about. But in general, I mean, I think it's a great job. Provides a lot to the community or to like society, but it's definitely the market is pretty saturated right now. I passed FizzBuzz, so I'm a SWE now. That's funny. Triumph. FizzBuzz, bro. Is that a LeetCode code question? We did FizzBuzz in one of my courses. Like that was like the first thing I did in computer science was FizzBuzz. Would you want to work in computational mathematics with applied physics? Oh yeah, that sounds really cool. Oh yeah, you're the kid from UIUC. Yeah. FizzBuzz was in CS 124. Yeah. Is FizzBuzz? I think it's also a LeetCode code question. Oh, my Google Chrome keeps freezing. Yeah, FizzBuzz is a LeetCode code question. It says super duper easy on LeetCode code. No, I'm just trolling. It is an easy question though. Yeah, no, computational math with applied physics sounds really cool. SWE is great if you love it. Yeah, of course. Yeah. No, I know software engineers have great lives. I know the people who worked like 10 hours a week are now getting fired, but if you enjoy it, working 40 hours a week in software engineering is pretty relaxed. What do you think of the semester project they gave us for our intro to CS course? Is it like a standard project? Why aren't you interested in SWE? And how do you get through the CS stuff not being interested in SWE? Well, I'm just interested, yeah. Rob answered the question for me. I was gonna go on this whole tangent, but Rob answered it in one line for me. You'd invest in your own electrical engineering company? Like start a business? That's pretty cool. Yeah, a lot of math majors do get into SWE and data science because it's so math heavy. But I love computer science. I love computer science. Using computers to solve problems is like amazing. It's like the essence of what I want to like go into in the future. But like it depends. It depends on what you're talking about. Software engineering is also a very broad term. So there's obviously some things that I like in software engineering, like some algorithmic stuff that I enjoy doing. But do I think I would want to maybe pursue a job in software engineering? Probably not. Coding is fun. Yo, what's up, Sweden? It's so hot in Texas. Yeah, it was hot here. It's going to be hot here on Monday. It's going to be 30 degrees, 30 something degrees. I think it's going to be like 33 degrees or something. It's going to be crazy. It's going to be 35 degrees on Monday. Oh my gosh. Probably die. Is it going to be sunny too? Oh, it's going to be windy. UV index is going to be 9. 36 degrees and a UV index of 9. You probably die if you step outside. Love the heat. Why do you like Celsius, LOL? Celsius is better, but like in all my courses, I use Celsius because it's like standard for physics. But Celsius is just like a little bit better for real life than Fahrenheit because it's more standardized, right? 0's freezing, 100's boiling for water, at least. For both of those are for water. Fahrenheit is good, actually, for weather, but it's just, like, really weird. But Fahrenheit is really good for weather because it's more precise than Celsius for moderate temperatures. Like, between 100 degrees Fahrenheit and 20 degrees Fahrenheit, it's much more, like, precise than Celsius. But just for weather. That's like the only real application of Fahrenheit. Kelvin is more precise? Well, Kelvin would be the same as Celsius because the relationship between Kelvin and the relationship between Kelvin and Fahrenheit is I don't know if how to characterize it, but I guess it's like linear. You just add a constant to Celsius. So like Kelvin and Celsius' rate of change is the exact same. But the rate of change of Fahrenheit is 5/9 the rate of change of Celsius. So it's like Fahrenheit literally moves at a slower pace than Celsius. Fahrenheit is basically a scale where 78 degrees means it's 78% warm. 78% out of what? Like, what is 100% in that ideology? Like, 100 degrees Fahrenheit's 100%, but we go over that a bunch. And then that would mean that 0 degrees is 0%, and we go below 0 degrees all the time. So I don't know. Would you be a physicist for SpaceX? Probably not, no. I honestly don't want to be a physicist, like, necessarily. Like, I don't want to go into, like, pure physics after I graduate. But I do enjoy studying physics. I don't know, dude. I don't know. Maybe I would be. Who knows? Who knows? I don't have a clue of Fahrenheit. Yeah. Oh, you were joking about Kelvin being more precise. Yeah, no, there's no need to learn Fahrenheit. Celsius is plenty sufficient. Have you looked at Maths 55? I've heard of it. I just saw a YouTube video on my recommended about it. I have no idea what it is, though. I hated chemistry in high school. I used to like biology and physics. Physics was the best. Yeah, chemistry is a pain. I'm taking it right now, but I kind of have not been doing anything in the class at all, so. This is physics, what I'm doing, even though it does look like it's pretty chemistry. You're welcome. Thank you, bro. What is the direction of the electric field in this case? So we know the direction of the force. Is the force in the same direction as the electric field? I think force and electric field go in the same direction, no? Yeah, they should. So force is in the negative I hat direction. Fuck. Do you use React for your website? No, I used vanilla JavaScript and oh, magnetic force and electric field are orthogonal to each other. Wait, so how the fuck do I know which direction the electric field goes in? It's gonna be the same answer. Where's my calculator? I'll just plug in the exact number. 7.8975 times 10 to the third. It's the same. What is the direction of the electric field? Okay, wait, let me think about this. A particle with initial velocity v0 enters a region of uniform magnetic, electric and magnetic fields. The magnetic field in the region is in the negative k hat. Wait, if v is positive j hat, this is positive j hat. B is going to be in the negative k hat direction, so it's into the page. Or is that positive? No, positive. Oh, wait. This is a positive charge. Wait, what? I did it with my left hand. It's positive I have. Oh my gosh. This is a message to buy Doge, he says. Yeah, no, I think that's actually what's going on. Oh my gosh, they never stop. Perfect. Okay, so the force, so this is something I need to remember. The force of the B field is going to be the same direction as the electric field. What is the direction of the electric field if the charge is negative? Now we use our left hand and we go down velocity. Wait, thumb goes to velocity, fingers go to B field. Wait. Thumb goes to the velocity. Wait, what? Hello? Thumb goes into the direction of the velocity. Fingers go in the direction of the V field in the palm. Oh, so that's how I got positive. Wait, so then how do you get force in the positive I hat? Bro, what? No, I get force in the negative I hat. Is my K hat wrong? Is it supposed to be into the page? Wait, you still get to the left. Or is it supposed to be... Wait, it is into the page. Yeah, so I get left. If we get out of the page, then it's to the right. Yeah, so I was right. F sub B is in the negative I direction. Oh, that makes so much sense. Oh my gosh, I'm an idiot. So this is supposed to be balanced. This is supposed to balance, so F sub E is going to point this direction and the positive I hat. And so now the E field points in the same direction of the force of the electric field, so it goes in the positive I hat. Okay, and now if we have a negative charge, then we use our left hand, points towards velocity, and our fingers point this way, and now we get force of B in the positive I hat, so we get force of E in the negative I hat. This is bullshit. How is this also in the positive I hat? This is so stupid. I hate my life. Why does it become negative J now? Oh. Oh, since it's negative, the electric force is opposite to the direction of the electric field. Oh. That makes sense. So I was right. It was just I didn't know that the force and field are opposite. Parallel plate capacitor, bro? Fuck you. Yeah, right, because that's what I did. It's such an idiot. It's literally not what I wanted at all, but whatever. Alright, let's draw these parallel plate capacitor. And then our battery. Conventional current flows in this direction. And we have a charged particle with bruh. Right. Charge plus 2 electrons. Okay, Q equals plus 2 electrons. What's an electron? 1.6 times 10 to the 19th? Negative 19th? 1.6 times 2. 3.2 times 10 to the negative 19th coulombs. Okay. And mass equals 6.64 times 10 to the negative 27th kilograms. Is accelerated from rest through a potential difference of 1.5 kilovolts. And enters the region between the plates perpendicular to the electric field as shown. So the magnetic field, or the electric field, the electric field is going to go in the same, okay, wait, hold on. Current is flowing this direction. So our B field is going to go on the inside, our B field goes into the page. And on the outside, our B field goes out of the page. And this is going to be our E field. It is going to flow from positive to negative, yeah. Okay, wait, let me think. Okay, so we need to solve for the B field. We need to calculate the B field. Well, interesting. Interesting. We have a couple ways to do this, actually. Oh, no, we don't. No, we don't. Because the force of the B field is just acting on the particle. They're perpendicular. Yeah, but somehow we have to use the capacitance. Somehow we have to use the capacitance. Capacitance equals K epsilon naught A over D. Oh, because we need to solve for the force of the B field. The force of the B field is going to be equal to the force of the E field. And the force of the E field is going to equal what? KQQ squared. It's Coulomb's law. Oh, but a better thing we could use is the change in potential over the distance. Wait, but then why do we need the area? We don't need the area then, right? Oh, because we need to solve for velocity? But we also don't need the area for that. We know half mv squared equals equals what? Q. Wait, half mv squared equals q delta v. Wait, so why do we need the area? We could use Coulomb's law, though. Yeah, I mean, let's try Coulomb's law. KQ over R squared. Okay, big Q is going to be equal to C times V, so K epsilon naught area times delta V, voltage of the battery, so this is just little v, or not little v, no delta, over the distance. Okay, V equals 2Q delta V over M. Square root of 2 times Q. 3.2 times 10 to the negative 19th over, times delta V, 1.5 times 10 to the third over mass is 6.64 times 10 to the negative 27th. The velocity is 3.8 times 10 to the 5th meters per second. Now we need to solve for force. F should equal delta V, which is 1.5 times 10 to the third over distance, which is 8.2 times 10 to the negative third. Wait, that makes wait, what? Oh, and that's not the force. That's for sure not the force. So should we use Coulomb's law? Yeah, that's probably not right. Okay, let's try Coulomb's law. 9 times 10 to the 9th times, oh, big Q. Gosh damn it. So we need to calculate big Q. Big Q is 9 times 10 to the 9th times epsilon naught, which is 8.85 times 10 to the negative 12th. Times area, which is 28.5 times 10 to the negative 4th, times voltage, 180 over distance, 8.2 times 10 to the negative 3. Okay, we get the charge is equal to 4.983 coulombs. Bro, that's like not, that's also like not possible. 9 times 10 to the 9th. It's way too large. For distance squared. No. No, this isn't right. This isn't right. Okay, should we try that other force? I mean, that's just a crazy amount of newtons is the only problem. Like, to the 5th, bro? I mean, we can try it. Okay. To the 5th divided by... What are we solving for? The B field? Divided by the charge, 3.2 times 10 to the negative 19th times... velocity, 3.8 times 10 to the 5th. Oh, hell no, that's not the B field. 100% that's not the B field. That's funny. No, it can't be 4.83 coulombs. Oh wait, I guess it could be. Per second. 4.983 coulombs per second. That's crazy. Gosh fucking damn it. Okay. Is accelerated from rest. What's the distance? 8.2 times 10 to the negative 3. So I'm getting an E field of 5.5 times 10 to the 12th. This is gonna be what? Farads? No, not farads. What am I saying? Wait, yeah, farads, right? Right? Might be voltmeters. Might be farads. I don't even know. So force is equal to the charge times that. 3.2 times 10 to the negative 19th. Okay, this looks a little bit more realistic. So we take that divided by Q, which is 3.2. Oh, wait, did we calculate this wrong? No, we didn't. Okay. Force divided by 3.2 times 10 to the negative 19th. Velocity. Ten to the 7th again. Is that the same we got earlier? No. This is fucking... So then, like, when does the area come? This times Q, which is 3.2 times 10 to the negative 19th. There we go. 5.7766 times 10 to the negative 2 Teslas. Oh my gosh. Bro, so what was the point of even having area, this voltage? Oh, I needed this voltage actually. What was the point of having area? Or mass? See how it calculated it. Yeah, it did the exact same thing I did. So dumb, boo. What is the direction of the magnetic field? Fingers in the direction of velocity. Or no, thumb in the direction of velocity. This is a positively charged. Positive charge. Direction of velocity. Wait. Bro, wait, this is also a stupid question. The direction of the magnetic field where? Here? Inside the plates? Okay, well, in the picture, it's gonna be this way. This is gonna be out of the page, so it's gonna be straight down. Fucking hell. Out of the page. That was one of the stupidest questions I've ever seen in my life. So you never use Coulomb's law or anything like that. Oh my fucking gosh. You got to be kidding me, dude. Fucking hell. What is going on here? A long wire carrying 4.5 amps of current. Okay, that's I equals 4.5 amps of current makes two 90-degree bends as shown in figure 1. The bent part of the wire passes through a uniform. Oh, this is not a vector. B equals the, well, let's just do 0.244T. The bent part of the wire passes through a magnetic field directed as shown in the figure and confined to a limited region of space. Find the magnitude of the force that the magnetic field exerts on the wire. Force of magnetic field equals the charge times the velocity. Oh, this is a wire, sorry. The current times the length of the wire as a vector with the cross product of B of the wire, the B field of the wire. So magnetic field region is in the blue with the B field going to the right. Or the B field going into the page? Or out of the page, I meant? Okay, the B field's going out of the page. And the current is flowing always at a 90-degree angle. So F of B is going to be equal to ILB, where we have the magnitudes of the vectors. Because this is equal to IL sine theta times B, and theta equals 90 degrees always, so sine theta is equal to 1 always, because they're in different dimensions. The B field is going out of the page. So you're in the direction of the current with the B field going out of the page. So we have our force pulling us down. Magnitude of the force that the magnetic field exerts on the wire. Okay. What? The dots is meaning like the B field's out of the page. Okay, so that means that the total length is going to be equal to 90 centimeters or 0.9 meters. The total length of the perpendicular wire is 90 centimeters inside the blue region. Because we have 60 plus an additional 30 when we change directions. Okay, so now we can solve for f of B. F of B is equal to 4.5 amps times, here, let's write it out. 4.5 amps times 0.9 meters times 0.244 Teslas. 0.9 meters times 0.244 Teslas. We get 0.9882. Bro, what is this? 9882 newtons. 0.9882 newtons. Incorrect. Okay, wait, let me think about this. 4.5 amps, 9 meters. Okay, I assume it's because of our length is incorrect, obviously. The B field is pointing out of the page. So our current is traveling. It's supposed to be like this. These are both perpendicular, bro. What the F? B. Yeah. Didn't think so. What? No, that's wrong. Fuck. Bro, is it high? Yeah. Find the direction of the force that the magnetic field exerts on the wire. Clockwise from right direction. Okay, so we have the current traveling to the right. Wait, but the force makes a triangle. The fuck does it mean clockwise to the right direction? Current's flowing that way. B field is flowing out of the page, so we get forces down. When it's going up, B field is going out of the page, forces to the right. So the components are to the right and down. So this is the horizontal from the right direction. This is the right direction. The force is going that way. So to go clockwise from the right direction, we have to go all the way around. Wait, what? Is this being serious? That's the plus X direction, and this is the minus Y direction. Clockwise or counterclockwise? Oh, clockwise, so it's this angle here. That's easy money. Okay, I bet. So this is gonna be 0.244. Oh, 0.3. So the vertical is gonna be 0.3. And the horizontal is the 60 centimeters. Is going to be 0.6588. So we get arc tan of 0.3294 over 0.6588. 26.565. 26.565. Are you fucking kidding me? Are you fucking kidding me? Okay, let's try the other. Bro, what?
Hey, sweetie, I'm heading out. Do you need anything from out?
straight
Do you
wire.
have something for Daddy?
So the B field is going upwards. Is oriented so that the current in it is running from west to east. So this is going this direction, west to east, and this is I as a vector. So put your thumb in the direction of the current. So you, that's for a point charge. I guess it's the same thing. Yeah. So we put our thumb in the direction of the current, our fingers in the direction of the B field. We get a force coming out of the page. We get a force directed out of the page. Yeah, correct. Okay. Find the magnitude of the force that our planet's magnetic field exerts on this wire if it is oriented so that its current is running from west to east. So it's still the same current running from west to east. So a Gauss. What the fuck is a Gauss? Let's figure out what the hell a Gauss is. Okay. 1 Tesla is equal to 10,000 Gauss. So 1 Gauss is equal to 10 to the negative 4 Tesla. Right? Yeah. Okay, perfect. So now we want our Gausses. So we have 0.55. We have 0.55. Wait, what are we trying to calculate? The force? The force is going to be equal to current times the B field times the length. Oh, my AirPods just died. Okay, wait, hold on. You were saying what? Which Linux distro are you using? I think it's Ubuntu. It's Ubuntu 2404 LTS. It's 2404. It's the newest Linux. It's the newest Ubuntu LTS. Okay, so the current we were saying was 1.5 amps. Our B field is going to be 0.55 times 10 to the negative fourth, or 5.5 times 10 to the negative 5 Tesla. Hold on, let me do that. 0.55 times 10 to the negative fourth. There's 5.5 times 10 to the negative fifth Tesla. And then we get that times the distance of 3 meters. And that's going to equal 1.5 times 5.5 times 10 to the negative fifth times 3. And we get 2.475 times 10 to the negative fourth newtons. Okay. Find the direction of the force if the current in this wire is running vertically upwards. Okay. So now we're getting our current is running out of the page. Our B field is still going north. So we do our thumb in the direction of the current out of the page. So we have our force is going to the left, which is west. The force is directed from east to west. Nice. Find the magnitude of the force if the current in the wire is running vertically upwards, and it is the exact same, 2.475 times 10 to the negative fourth newtons. Find the direction of the force if the current in the wire is running from north to south. So this is saying the B field is running from south to north, and our current is running from north to south. There is no force exerted on the wire. That is correct. Find the magnitude of the force, 0 newtons. Is the magnetic force ever large enough to cause significant effects under normal household conditions? What the fuck? I don't know. Dude, what? What? What type of question? Ever large enough to cause significant effects under normal household conditions? No. What is that, amps? The amps is 1.5 amps? Yeah, hell no, dude. If I had a 1.5 amp wire, it's not gonna make any effect on the real world. I mean, look at the newtons. It's 2.48 times 10 to the negative fourth newtons. No. That's a stupid ass question though. Butchered this homework assignment. 94.7. That's so bad. 79% on this question. Bro, Google Chrome keeps freezing. I don't know what's going on. This is unbelievable. 79% on this question. Unbelievable. It's terrible. It's like one of my worst homework assignment grades. Yeah, that's abysmal, dude. 94.6, wow. That's not good at all. Okay, so now I can just do some calc. Oh, I guess I still need my iPad then. Open that back up. But we can, actually we can just just bring it over here and close that terminal. Oh, this is supposed to be in the middle, I forgot. And we use this. Yeah. Let's go to calc. Doesn't change any. Oh, that's the volume. Brightness doesn't change anything. Are you fucking serious? Avrix. Hey man, do you know how can I get scientific articles and paper for free? I get all of my articles from Avrix. Or you can get them through your school. I get all of them from either Avrix or through my school. My school provides like pretty much all of them, but Avrix. But I think Avrix only has computer science. No, Avrix has all, yeah. Avrix. Avrix is the best place to get papers from. Any subject. I use it for computer science mainly. But they literally have every paper ever made, and you can search it. Attention is all you need. The greatest paper of all time. Conversation is all you need. Hello, dude. Okay, well, their sorting algorithm is ass. Okay, so we need to find the equation of the plane that contains the lines x equals 2 plus t and is parallel to the plane. Okay. Okay, I should be able to do this. Planes. Yeah. Isn't it just... So here's our equations. X equals 2 plus t, y equals 3 minus t, and z equals 5 minus 3t. We have our equation 5x plus 2y plus z equals 9. So we have 10 plus 5t, I guess it doesn't need parentheses, plus 6 minus 2t plus Oh shit, we forgot the y. Oh wait, no, we don't need that. Plus 5 minus 3t equals 9. And now we just combine 5 minus 2 minus 3, so it's 0t. Wait, but this doesn't work, so we just get 22 equals 9. Wait, hold on, somewhere our math is off. We have 5 times 2 plus t. Bro, what? This is calc 3. Okay, can we go to exercises? I need to make sure I'm doing this correctly. Alright, what chapter is this? This is lines, planes, and distances. Exercises. Okay. There should be...
Yeah, what's up, brother? I didn't see you call, my bad.
Wait, Jay, what are you saying? And your points from the line 2, 3, 5 in form of x, y, z? Oh. Oh, so it equals 0. Why does it equal 0? (16 plus 5). We had 21. (5x plus 2y plus z equals 21). Is that right? Okay, so what I did... Wait, but what happens to the equals 9? Like, I just plugged in x, y, and z into this. Is that not right? So the normal vector of this is 5, 2, and 1. And now we plug the normal vector in and set it equal to 0. Okay, wait, let me do another. I'm gonna do this one here then. Okay, so if x equals 1 plus t, comma, y equals 2 minus t, and z equals 4 minus 3t, and parallel to the plane, 5x plus 2y plus z equals 1. Okay, so we get the normal vector 5, 2, and 1 is the same normal vector. And we plug that in, so we get 5 plus 5t plus 10, plus 4 minus 2t plus 4 minus 3t equals 0. These cancel. We have 5 plus 4 is 9, plus 4 is 13. So we get 5x plus 2y plus z equals 13. Right? Is that how I do this one here? Let's see if that's the right answer. There's no answer in the book, but yeah, 5x plus 2y plus z equals 13. Okay, so my answer is correct. So, yeah, that's a way you can do that. Alright, so you just get the normal vector, plug these in for the normal vector, and set it equal to 0, and then you solve that, and you set you need it to be parallel to this one, so you just make it equal to that. Whatever. Alright, but, I mean, that doesn't really make any sense, but, alright. Give the normal vector n1 for the plane. Okay. So the normal vector is going to be 4, 16, negative 12. Right? That's the normal vector, right? Yeah, okay, good. Give the normal vector n2. So we get negative 21, 42, 49. Find n1 dot n2. Okay. This is going to be 4 times 21 plus 42 times 16 minus 12 times 49. Okay. We get 84 plus... Wait, let's see. 6 times 49 times 6 is 54, 24, 29. Okay, whatever. We'll just write it out. Okay. So 588 plus 84. Bro. Is equal to 0. So they're parallel. Wait, that means they're perpendicular? Wait, I thought if their dot product equals 0, then they're perpendicular? Huh. So if the dot product equals 0, then they're orthogonal. Wait, but why? Wait, let's think about what a dot product means. I don't know what a dot product means. I just know what it is. Whatever, if the dot product 0, oh, so it's the cross product is 0, then they're parallel. Well, the matrix would be zeros. Or if their normal vectors are differing by a multiple. Consider the following planes: x plus y plus z equals 8. Find parametric equations for the line of intersection of the planes. Okay. This is parametric equations. Wait, what's the line of intersection between two planes? Oh, I'm losing that song like 50 times already. How long do you know I've been? Wait, how do I find the intersection of two planes? Okay. Oh, I should solve this one for x, actually. It's easier. Well, actually, I should have just kept it as... I should have used these. These are easier, actually. Oh, I guess it's the same. It's the same. It's the same. Yeah. The A's cancel. Y equals Z. What do you get? Wait, is it negative Z then? It's negative Z. Y equals negative Z. Y equals negative Z. So we get Z equals T. Get Y equals negative T. And X equals 8 minus 8 plus T minus T. X equals 8. Wait, is this pot? That can't be right. Like, there's actually no possible way. Oh, I shouldn't have put equal signs, first of all. But I think it's still wrong. It's right? Oh shit, look at that. Find the angles between the plane. Okay. So we get cosine of theta equals n1, n2 over the size of n1 times the size of n2. right? Yeah. Okay. N1 equals 1, 1, 1, bruh. N2 1, 7, 7. Wait, N1 times N2. Oh, dot. N1 dot N2. So we get 1 plus 7 plus 7. 15. Over 3 root 33. So we get 5 over root 33. So we get cosine to the negative 1 of 5 over root 33. I got 24.5 degrees. Yeah, right. Hey, wait, we have like the same answer. Except mine's root 33. Cosine the negative 1 of 5 over root 33. Rounded to 1 decimal place. I'm just gonna put the whole entire number in here. Wait, let me just make sure this is the same thing. We get 15 over 3 root 33. Yeah. Oh, because I put the wrong fucking number in here. It's 29.5. Wait, is that what I put? Nope, obviously not what I put. What did I put? 24.5. Yeah, I just put in the wrong number by accident. It's like a typo. What does the equation y equals x squared represent about a curve in this second degree plane? A parabola. What does it represent as a surface in the 3D plane? A half cylinder. I don't know what any of these words mean, but it's like a cylinder, but a parabola. Wait, is it the area inside the curve or outside the curve? It's inside. Oh, so it is going to be a parabolic cylinder. What does the equation z equals y squared represent? I don't fucking know. Z equals y squared? That's just a parabola, but in the other direction. It's going to be a parabolic cylinder. They're the same thing, except one just expands in the x direction, one expands in the z direction. Match the equation with its graph. Okay. X plus 7y plus, what is this, 8z equals 1. This is just a cylinder, or not a cylinder, a sphere with a radius 1. It's a circle with radius 1 here. I think it's something like this. I don't like walking around this old and empty house. On the hands I walk with you, my dear. Yeah, I mean, I think that's the right answer. So is this one. It's a sphere. I know it's a sphere, but I don't know how to tell which orientation it is. How do you know which orientation it is? Oh, because the circle's supposed to be in the XY direction. Oh, but that is like the same thing. I'm so confused. Can we go to GeoGebra? It will be over and the hell is this? Okay. Yeah, it goes from 1 to 1 on the x-axis. What is its radius around the y and z axis? One-seventh? Oh, that's how you can tell. It's 1/7 z and 1/7 y. So the x is going to be the fat one, and y and z are going to be skinny. Okay, this is another cylinder. Wait, but it has a subtraction. What does subtraction even do? Oh shit. Wait, what the fuck just happened? What the fuck is going on, dude? Where are the axes? What the hell is going on? What the hell is this? Wait, why is it like that? Y equals 0. Wait. What the fuck is going on? Wait, dude, are you fucking high? Okay, wait, can we go to self-service? Wait, my first exam is in 13 days? What the fuck is going on? like this. And like this. I don't know what the hell is going on. This is blowing my mind. Okay, well, cosine only goes between 1 and -1, so either one of these two. But the x component is negative cosine t, and the y component is t. It's going to be this one. Because x is going to be between -1 and 1, and y is just t. Y equals t. So it's kind of like parametric equations from Calc 2. X equals 6 sine t. So at 0, sine is 0, and cosine is 1. So we're going to have 5, 0. 5, 0 is going to be a point, so both of these. But at cosine, wait, and then when t equals, I guess we'll just go to pi over 2. When t equals pi over 2, sine is 1 and cosine 0. So sine is 1. We're going to have 6, 0. So it goes counterclockwise. As t increases, it moves to the like that way. Fuck. So it's going clockwise? How the fuck do I know that? Wait, what? Oh, I'm an idiot. No, it does go clockwise. Yeah, 6 is the x. X is 6 and y is 5. X is 6 and y is 5, and it goes clockwise. Yeah. No, I was right. It goes clockwise. Wait, did I choose the wrong graph? No, I choose the right graph. Wait, why does it go clockwise? Whatever. Match the parametric equation with the correct graph. X equals t cosine of t. Y equals t. And t x. So we have 0. So at 0, at t equals 0, we're going to have the point. Oh my gosh. There's so many graphs. So x and z are not going to be greater than 1 and -1. So that's the y-axis is between 1 and -1, so that's not right. What the hell are these graphs? Z is going to be between -1 and 1. And x is going to be between -1 and 1. So z is between -1 and 1. X is between -1 and 1. And for some reason, y is also between -1 and 1. But why? I think it's that one, though. No, the only problem with this is that x is not between -1 and 1. Yeah, same with this one. And oh, this one x is between -1, but z is not. With z equals 100. Yeah, same with this one. Well, -1 and 1. Z is also between -1 and 1. And y just does whatever it wants. Wait, it's either 1 or 2. What the hell is going on? Yeah, right. I don't fucking know. Okay. I have to leave. Hello? Yeah, I'm leaving. Okay, join the Discord, and I'll be streaming tomorrow again, probably around, I don't know. I'm gonna try to get up at like 8 a.m., but yeah. Goodbye. I'm ending stream.